Welcome back at C Squared. In this lesson we'll talk about coordinate proofs, but at the beginning we're gonna talk about how to position figures, and in this lesson we're gonna talk about triangles in a rectangular grid in such way to be useful. So what do I mean? You have to follow some steps to position your figure. So one of the things that you're going to do is use the origin as a vertex or the center of the triangle, I said here. Place at least one side of the triangle on an axis, x-axis, y-axis, you will see. I'm going to do that. Keep the triangle in the first quadrant if possible. And use coordinate that make computation as simple as possible. So follow these 4 steps. And let's see how we do that. In this case, we have this triangle ABC. This is a right triangle. And one of the leg is 2A units and the other leg is B units. So how do I position this in a rectangular grid? One way, it's right here. You see, like I said, one of the vertex A, is right here at the origin. AC is on this x-axis and AB is on the y-axis. Obviously it can be the other way without any problem. And if you take a look, AC is B units, so this point here is gonna be at B and 0. Very important to see that. And since the other leg it's 2A units, this point B will be at 0 and 2A. So that will be one way to position this triangle. For isosceles triangle, you may want to use the property of this isosceles triangle, and you may want to position the vertex of the isosceles triangle, the point where the 2 legs intersect, on the y-axis, I said here. So let's see this example where we have to position a triangle ABC. Triangle ABC is an isosceles triangle, very important. With the base AB, the length of AB is 2A units, I'm sorry, and the height is B units. So like I said, you may want to do something like this. This is the x-axis, this is the y-axis. Now you notice I kind of use the fact, and by the way, you see here these 2 legs are congruent. This is the vertex, and I use the fact that this isosceles triangle has these 2 pieces congruent, right? And if you take a look, the length of AB is 2A units. So the length of AB is 2A units. I think I should have said here the length of BC. Yeah, the length of BC, it's 2A units. So which means nothing else than this point here, C, is at A and 0, and this point B here is at negative A and 0. Now the distance between B and C now will be 2A units. Okay. And I use the property of the isosceles triangle, which tells us these 2 pieces are congruent because the height, which is this segment here, is also bisect the base, in this case BC. And one more thing, we have the height of ABC is B units, so that means this point A is at 0 and B. In my next case, we look 2 examples where you need to identify missing coordinates. Okay, so in this case and this example, we have this right triangle. We can see it here, but also this is also an isosceles triangle, very important. And we know that this point C is located at 3B and 0. So we need to find the other coordinates. Obviously the point A, it's at 0 and 0, and the point B here will be at 0 and 3B. Why? Because one more time we notice these two legs of this right triangle, isosceles triangle, either way will be good, are congruent, so they have the same measure. AB will be also 3B units like AC, which is also 3B units. Okay. In the next example, we have this triangle, which you notice is an isosceles triangle. Why? Because we notice these two sides are congruent. And this triangle MPN, what do we know? We know this point N is at 2B and 0. And we know this piece here is congruent to this piece, right? This is a property of an isosceles triangle. So let me write that here, triangle MPN isosceles. So obviously these two pieces are congruent. So what are going to be the coordinates for P? That will gonna be negative 2B and 0, because they have to be congruent. So we identify the coordinates of point P. We have one more point, point N, and we notice this point is on the y-axis where the x-coordinate is 0. So here we have 0 and that A. And that's it for this problem. My next example, very similar. We have now an isosceles right triangle. So let me write that here, triangle MNT is an isosceles right triangle. A very, very special right triangle, or a very, very special isosceles triangle. Okay, later you'll find out this has another important property. This isosceles right triangle is a special right triangle. Okay, so now we know what about this triangle. We know that this is the vertex at 0 and 0, and this point T is at 2A, and that is on the x-axis, so it's going to be 2A and 0. Now we have one more point, point N, this one. What is the location of point N? Since these two segments are congruent, since this MT and MN are congruent, we see that in the picture. That means MN and MT have the same measure. So if MT will be how long? MT is 2A units. You start from 0, an x of 0, and end up to 2A. That means MN should be also 2A. So if we're looking here, the y-coordinate of point M is 0. So what should be the y-coordinate of point N? That should be also 2A. And this point is on the y-axis, so this will be 0. So that is about this example. In my last part of this short lesson, we'll take a look to how you use, how you write the coordinate proof, and how you use this positioning a triangle in a coordinate grid for writing a coordinate proof. So we have here this triangle ABC. We notice is a right triangle. It is also given in the original statement. We know point D is the midpoint of BC. These two segments are congruent. That is the meaning. And point E is the midpoint of AC. That means these two are congruent. So what we have to prove now is that DE, this we call this one a mid segment later, is half of this third side AB. So the first thing you're going to do is to position your triangle. So this is the x-axis, this is the y-axis. Okay, now to make the computation easy, I'm going to call this point B here 2A, and obviously it's 0, the y-coordinate, because this point is on the x-axis. Very similar, point A is going to be 0 in fact, because it's on the y-axis, right? And 2B. So you notice I don't call just A and B, I make it 2A and 2B. Why? Because that will allow us to position this point D. This point B, it's going to be A and 0. Why? It's halfway between B and C. So if BC it's 2A, since D is a midpoint, then CD should be only A. That's the reason I'm going to say A and 0. Very similar, I'm looking to the other side where AC it's 2B units, right? Because it starts from this point C, which adds 0 and 0 by the way, and point A it's a 0 and 2B, so that segment should be 2B. Now E is a midpoint, so probably I should have put here a midpoint, the midpoint in fact, because it's unique. Sorry, let me go back. Okay. So how long is going to be, for example, CE? CE will be only B units, half, right? So this point here, it's going to be at 0 and B. So now we're going to need to find the length of these two segments, DE and AB. So I'm going to use the distance formula, which looks like this: D equal square root of x2 minus x1 square plus y2 minus y1 square. And let's start with DE. The point D is at 0 and B. The point, I'm sorry, A and 0, the other way. A and 0, and point E is at 0 and B. So using the distance formula, the length of DE will be square root of what? X2 minus x1, 0 minus A, for example, if we go that way, if we consider point E the second point, plus y2 minus y1, b minus 0, right, square. So we get here square root of 0 minus A is negative A squared is A squared plus B squared. That is how long DE is. Now we're going to do similar for the segment AB. I'm sorry, and the segment AB, we're going to do the same math. And let me be consistent. Point A is at 0 and 2B, and point B is at 2A and 0. Distance formula one more time. So we have AB equal square root of, and now we have, let's say point B is the second one, right? So we're going to have x2 minus x1, so it's going to be 2A minus 0 square plus y2 minus y1, 0 minus 2b square. And what do we get here? We get square root of 2a squared, which is 4a squared, plus 0 minus 2b, it's negative 2b, negative 2b squared is going to be 4b squared. Now what can we do there? We can factor out the 4 inside of the square root. and we can break this product, the square root of a product, in a product of square roots. And if you notice, square root of 4 is nothing else than 2. So now let's take a look to this AB and this D. If you notice, AB is twice DE. Why? Because we have 2 times square root of A squared plus B squared. 2 times DE. Okay, so obviously DE, if we divide by 2, is going to be half of AB, and or 1/2 times AB. Either way is good. So this is what we call a coordinate proof, where we draw an x and y axis. We label the points in such way to make the computation easy. And you notice these 2a and 0 and 0 and 2b, which allows me to handle easier the midpoints. And then we use the distance formula, and we end up with what we need to prove, that DE is half of AB. And my last example in this lesson is this one, where we have a triangle given AC is congruent with BC. So that means these two segments are congruent. Sometimes you may want to do that on the picture, it helps. And D is a midpoint of AB. So that is the meaning, the segment AD congruent with segment DB. We need to prove that CD is perpendicular on AB. So again, we're going to use this coordinate proof. I'm going to draw this x-axis. I'm going to draw this y-axis. And very similar, I want to make the computation easier. So this point, let's say, is here, and I'm going to say now M to M and 0. Now, if you notice, these two segments are congruent. It's given in this problem. So point A should be at 0 and 2M. Okay, so now point D here, which is the midpoint of segment AB. How do we find the x-coordinate of the midpoint? In this case, we could have point D. We're gonna, let me write the formula here. X-coordinate of the midpoint is you add the x-coordinates and divide by 2. So in our case, we have this point A, which is at 0 and 2M, and this point B, which is at 2M and 0. We're going to add the x-coordinate, 0 plus 2M, and divide by 2. We're going to end up with 2M over 2, which is 2. Very similar, we're going to do the y-coordinate of point D, which is, if you remember, you have to add the y-coordinates and divide by 2. So we're going to have 2m plus 0 now over 2. We get 2m over 2, which will be only m. And I'm sorry I put 2 on the other side. Here is going to be m also. So this is m. So this point D has the coordinates m and m, which I think makes sense if you take a look at the picture. So now we want to find the slope of two segments CD, and also you'll see I'll find AB also, and we're going to take a look to those two slopes. Slope of CD, if you remember, the slope formula says what? y2 minus y1 over x2 minus x1. And since we talk about CD, let's see, the point C is at the origin, and the point D is M&M. That's the reason we want to find out. So the slope, okay, let me write just slope. I'm not gonna write the letter M. Slope of CD. Okay, that will be what? Will be y2 minus y1. So again, I want to be sure this one means slope here, nothing in connection with the m in the problem I used. So slope of CD will be m minus 0 over m minus 0, and that will be m over m, which is nothing else than 1. The slope of CD is 1. Now let's take a look to slope of AB. Okay, and the point A is at, remember here, 0 and 2m, and point B is 2m and 0. So that slope of AB will be, and again we have y2 minus y1, we have 0 minus 2m over x2 minus x1, 2m minus 0. So we end up with this negative 2m over positive 2m. We can simplify the m's. We have negative 2 over 2, which is negative 1. And now let's take a look to these two slopes. The slope of CD is 1. The slope of AB is negative 1. These two are negative reciprocal, right? So because these two, the product, you may want to do like that. Slope of AB times the slope of CD. Okay, and I didn't use the letter M like I used to use usual, because we have this so many M's. We have 1 times negative 1, which is negative 1. That is a way to prove these segments are perpendicular. So now that will be my final step here. CD, segment CD perpendicular on AB. Why? Because the slope are negative reciprocal. The product is negative 1. If you enjoyed this video clip, don't forget to click the like button and come back on C Squared for more help. Thank you.